I'm here to talk to you about why clustering is awesome. But first, I thought I'd kind of explain why I'm here talking about this, because obviously most of you know me as an openSUSE guy. So what am I doing talking about HA and all that fun stuff? So I've been working at SUSE now for 2 years, well, under 2 years, and mainly as a QA engineer, mainly testing the HA high availability stack inside SUSE Linux Enterprise. And of course, more recently, also testing with OpenQA. But really, I've been, for the last 13 years now, working as a sysadmin, working with HA. We were, at my college where I used to work, we were really early adopters of high availability clustering. I mean, we're talking about the time like when iSCSI was first invented, before I was using Linux. So we had NetWare servers, and I was trying to get iSCSI running on NetWare, and I phoned up Novell, and they said I was crazy. So I built it anyway, and then I ended up with this really weird cluster of machines that had 5 machines running, 2 storage boxes, all these wonderful high availability stuff, so I could run all of my services at my university on this bizarre hybrid NetWare monstrosity. And then Linux came along about 3 years after I started doing that, and that's about the same time I started contributing to openSUSE. So for me, Linux, HA, openSUSE have all kind of got merged in my head in the same way, because that's kind of how I got started with Linux. We immediately replaced all of our NetWare boxes with Linux. iSCSI actually started working back then as well, so I could actually put load onto my clusters. And that's sort of the story of how I got started with all this. So now I'm talking about HA many years later, running on openSUSE and on SLE. So why do we need HA? Why do we need a keyboard that works? There we go. Why do we need high availability? What is it? So can anybody raise their hand? Are you using HA clustering in any kind of way at all? Linux, Veritas, the Microsoft one, a few. HA proxy, which isn't really what I'm talking about here, but is a high availability thing. So, okay, a few people. Who has no idea about what I'm talking about so far? No idea about what clustering is? Well, you don't count, you write it. But yeah, there we go. So yeah, I'll talk a little bit about why we need it, a bit about how it works, and I'll show you how you can install it and get it started running on openSUSE. So what is HA? It's high availability. I'm going to keep on calling it HA because high availability will make this talk 25 minutes longer if I keep on saying it all the time. I was looking up the Wikipedia definition of this, and the Wikipedia definition of high availability is completely useless. The definition of availability is uptime divided by total time, but this equation is not practical. So you must substitute total time minus downtime, blah, 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 blah. This is why you install HA. You want everything to just keep on working and nothing to break ever. On all of your servers, all of your systems, you just want everything to keep on working so your users don't phone you up and start screaming at you. But they will anyway, but maybe for just a little bit shorter. So when I first talked about this presentation, I immediately got people raising their hands and saying, yeah, but Linux is already stable. Linux is perfect. It does everything fine, And okay, I work in QA. I should be saying now that everything I've released is perfectly stable and has no bugs. But that's not true. Software does have bugs, and sometimes those bugs end up impacting services, and HA can actually surprisingly save you quite a lot with that. There's been plenty of times I've had issues with Linux boxes having weird kernel issues, hard locks, all that kind of stuff. And HA, because of the way it works, it doesn't really care where the problem's originating from. It will actually dive in, save the day, kill the machine, and you can keep things running again. A friend of mine is a really heavy BSD user, so at this point I like to quote Theodor Rath with his, Linux is never about quality. Which, of course, isn't entirely true, but there's an awful lot of moving parts in Linux. I mean, openSUSE now is at 8,000 packages in the main distribution. Having something like HA there, giving you an extra way of covering, keeping your services running is very, very nice to have. But really, also, we're not talking about software, when we're talking about HA, we're normally talking about hardware failures. Your server's in a data center somewhere or at your home, and this happens. And this isn't a photo of it actually happening to me, luckily, but I've actually seen this 4 or 5 times now in production with, for some reason, always SATA hard disks. I ran IDE hard disks for years, and they never caught fire. But I've had SATA hard disks do this on me now 3 times. One was really cool. A colleague was sitting in an office, and I just heard this scream, and looked around the corner, and then this huge puff of smoke flying out of his office. And the really funny thing is the cloud of smoke goes right over the fire alarm detector in the office, and then didn't set the fire alarm off. So we're like, okay, that's kind of weird. So 1 fire extinguisher later, we had a broken hard disk. And yeah, HA was kind of really built to cover these kind of bizarre, wonderful hardware failures. I've got a video here of the worst hardware failure I've ever seen, which this was actually one of my first Linux cluster production servers. And I logged in I came in one day, and luckily, this is a perfect HA success story. My phone wasn't ringing, everything was fine, and I log into Nagios, and this cluster node's dead. So I'm like, okay, weird. Fire up the serial console, nothing. Reboot it via the power switch, nothing. Get it out the lab, plug it into a connector, and that's the BIOS screen now. Never figured out what it was. We ended up replacing practically every single part in the machine, so it was a whole new machine when we were finished. But this is why HA is awesome, because you can have failures like this, which you can never explain, and your machine doesn't matter anymore. You can just keep the service running, keep everyone happy. People don't phone up and moan about it too much. But also, it's not just software and hardware that can let you down. These systems are running somewhere. People go to these places, normally workmen in data centers. Workmen have things like power saws, which cut through network cables, which is really not fun when that happens to you and half your cluster suddenly disappears. This has happened to me twice. I guess I'm just really unlucky when we have people come into our data centers. And we've also had plenty of cases, well, most server rooms, at least most server rooms that I've ever found, if they're on location at an office, normally end up being in the basement. And if you're really unlucky, that basement normally has quite a lot of plumbing going through it. You get a plumber come in, and suddenly you have lots of very wet servers. So this is also a very good use case for geo-clustering, having one cluster of servers in one location and another cluster somewhere very, very, very far away. And this is all stuff you can do with the HA software today that we have in openSUSE. So when I was growing up, I was a big fan of the A team, the HA team. But yeah, servers fail, HA's covering servers. So when we're talking about actually deploying HA and using it in production, we don't actually care about the server. It's a bit of a cloud mentality. You know, servers are expendable. You want them to explode. You want them to, you expect them to explode. You expect them to fail, and you want to be able to just walk away from the carnage, and your users carry on working with no problems. So the model in HA is basically all of your services are what you're configuring in your high availability software. And it's those services which are defined, and that's what's moving around your cluster, so it's still working. So when something fails or the server disappears, everything kind of goes like this and gets its load distributed across all of the other machines in the cluster. So in a very simple diagram, this is actually straight from the Pacemaker documentation, this is how HA works. You have, in this case, 3 physical servers. And in a traditional environment with old-style standalone servers, that would be your web server, your database server, and maybe some spare machine if you're lucky. On top of that, all you have to install is basically 2 sets of software called Pacemaker and Corosync. Corosync is the, if I'm going to get this wrong, you can correct me, but I'll be really embarrassed. Corosync is the communication layer, which basically keeps all of the cluster's machines talking to each other, make sure that they're there, that they're awake, that they can see each other and the network's behaving properly. And Pacemaker is the service manager. So if you want to think of it very simply, Corosync's kind of checking everything below that red line is working, and Pacemaker is actually what's defining everything in the green boxes. And so inside Pacemaker, you then configure your Apache server, and you're basically saying, okay, this is my Apache server, this is its config, and also you normally attach an IP address to that as well, because of course, if this is moving around your cluster, you can't give it the IP address of the actual web server. That might disappear. So you give it a portable IP address, which the machine has in addition to its local IP address, and that's what you move around the cluster with this resource, so your users can always get to the same web server and not realize that the machine it was on blew up 10 minutes earlier. And you can have ridiculous numbers of servers here. For the case of this discussion, I'm keeping this simple. The total number we currently support in Pacemaker is 32 machines on a maximum cluster. And the number of resources, I don't think we've tested. Well, I've tested it past 255, so you can do crazy numbers of resources if you feel like it. And quite a lot of these resources are already effectively pre-configured in the software. So all you have to really say is, it's an Apache server, there's the config, done, and HA will take care of the rest. There's not much scripting or complicated digging around involved. So when a server fails, let's say you have one of these physical servers, so in this case, one of the orange boxes, and one of these servers is sitting there doing both Apache and your database. When it fails, Pacemaker can, if you wanted to, actually then kind of split that load, so the Apache server goes somewhere, the web server goes somewhere else, sorry, the database server goes somewhere else, and you're keeping that load so you don't have a situation like you can with some HA stacks, where one server fails, everything falls over to your backup server, and then your backup server ends up being way too slow, way too laggy, everything just goes worse, and you've gone from a broken machine to a really slow machine, which your users still don't like because it's just too slow. So building a very simple cluster, all you need is 2 machines. It's not an ideal scenario, and I'll go into detail about that at the end, but all you need is 2 basic servers. And on top of that, for keeping with the traditional example, you have a web server like Apache, and maybe a file server like Samba, and then something goes wrong. Server number 1 fails. Might be a hardware failure, might be somebody cutting a cable, who knows? Doesn't really care. Pacemaker will detect or Corosync will detect the fact that the cluster node is no longer there. Pacemaker does this wonderful step called shoot the other node in the head, STONITH. We have wonderful acronyms in HA. And that server that's failed will then be killed. The mechanism of how that is depends on how you want to configure it. There's ways where effectively a poison pill gets sent and the kernel panics itself. You can point it at power switches, you can make it SSH and just do init 0. There's plenty of ways of killing a machine, and HA kind of supports all of them. So you end up with a situation where both your web server and your Apache server is running on the same box. But the web server still needs its files, and they were left on the other machine. So you have to worry about the storage as well, and this is one thing that a lot of HA beginners forget about, is, and then it gets really messy, because, something fails and it doesn't have the same, if you don't have the same version of the website running on the second server, well, your users suddenly get a nasty old version and it all goes horribly wrong. So there's plenty of ways of dealing with this issue, and there's certain recommendations, but the very easiest one is just use rsync. Define your folders that you're using for your failing over services, and make sure that both machines keep that kind of in sync with each other. It's not the most simple way, most ideal way, but it does the job, and it's really good for basic 2-node clusters. In a more advanced situation where you might want to have an absolute certainty that the storage on both nodes is absolutely identical on the block level, there's a very nice technology called DRBD, which basically lets you take a block device, so any hard disk or any block device at all, and basically transmit those blocks over the network to another block device as a network grade 1 mirror, basically. This is incredibly useful. At the moment, it only supports 2-node clusters. I think the plan's still to fix that so it can do multiple nodes, but I'm not sure if it's there yet. And that covers 2-node clusters pretty nicely. But in an ideal situation, what you really want is some kind of shared disk, something in between. So when I started out doing this, I've pretty much always liked iSCSI, even when it was a bit on the slow side, because you can just, at the end, get around it by using fancy tricks on networks, like port bonding and aggregation, and just, throw more network cables at it and the problem goes away. Or these days, you can just throw 10 gig at it and the problem also goes away. But fiber channel, whatever, all the various different shared network, shared SAN approaches all kind of fit in here. And if you're, really on the cutting edge of stuff, of course, things like Ceph, like SUSE have in their SUSE storage product, would be a natural fit here. I don't know anybody who's done that yet. If somebody has, please let me know, because I think that would be really awesome to write about. But yeah, that's something shared in between is the perfect approach for a HA cluster, because then you have a chance of doing this, which is, in my opinion, the perfect beginning situation for HA. With 2-node clusters, you have a fundamental problem. How do you know which one died? If cluster 1's dead, machine number 1 is dead, how does it know, or how does machine number 2 know that it isn't the one that failed itself? This is sort of the traditional split brain problem, where both machines are both monitoring each other, and then when one goes wrong, you don't necessarily know which one went wrong from the one that's still standing. Or put another way, kind of like this scene in Iron Man 2, where they're both just beating down each other. And in fact, when you have STONITH involved at the end, where the machine that fails gets killed by the other machine, you kind of have a situation like this at the end. And your cluster just kills itself because they both think they've both failed and you've managed to break both machines. So with a 3-node cluster, you never have this problem. Because if one machine fails, you have 2 of them that can say, okay, you're the dead one. Die, go away, disappear. Get yourself shot in the head. And everything carries on running. So when it comes to building a cluster, if you can afford it, stick with odd-numbered nodes. 4 has a problem too. I mean, if you had, like with the idiots cutting through the network cable problem, I've had that where I had a 4-node cluster split in half, and then I suddenly had 2 2-node clusters with storage split that was getting really, really messy. So build 3-node clusters, build 5-node clusters, try and avoid even numbers if you can, unless you're doing the whole DRBD thing, which you really need to stick with 2 nodes for that. So, but just be aware that you might have sort of false failures, which if it does happen, what's the point of installing HA? So installing HA on openSUSE is actually surprisingly simple. On Tumbleweed or 13.2, all you have to run, there's no add-ons, there's no extra repos, it's all in there in the main distribution, is zipper in HA cluster bootstrap. And this is effectively the nice cut-down script wizard that automatically asks you all the questions you need to install HA. So installing that package actually pulls down all the dependencies you need for the web interface and everything else inside HA. So on the first machine, you log in, you connect to it, and you run HA cluster init, which I will show in a minute. And this wizard basically asks you all of the questions you need to set up your cluster. So if you're using shared storage and you want to use an SBD for detecting the split brain so you don't have that situation with 2 nodes, it'll ask you that question. It'll ask you a few other things. To be honest, normally I just say yes to everything now, so I can't remember what they all are in order. And then that's it. You end up with a 1-node cluster, which is totally useless, but that's exactly what you need to then have your 2nd and 3rd nodes connect to. So you end up with you actually building your cluster, and to connect those other nodes, you just use HA cluster join. So Now I do a very, very quick demo of how that looks, with one rough edge I have to avoid. So zipper in HA Cluster Bootstrap. This machine's Tumbleweed. Can you read that? No, you can't. Wait. Is that readable now? Yeah, let me just make the font bigger, because it's important you can see the questions. Nearly there. Now I've probably made it too big. Yeah, okay. Let's just give up with that for a second. While I'm messing around with this, does anybody have any questions? Yes. Yep. Oh.
So we found that we were actually, by having it automatically shoot other nodes in the head and automatically fail things over, we're finding much lower reliability overall in the system.
That's a...
Because it needs, your high availability software needs to be many orders of magnitude more reliable than the underlying systems, or your false positive rate will be higher.
Yeah. So which software were you using, just to be...
This was Heartbeat version 1 and then early version 2.
Yeah. Heartbeat wasn't great back then. Software's changed a lot since then, luckily.
Yes.
Yeah.
But we find it's actually quite nice to have the monitoring system tell you when something's wrong.
Yep.
And have the tooling in place to be able to manually have a human make the decision about what dies.
That's actually one feature we do have in here. So with, like I said, with Pacemaker, there's lots of different ways of killing that machine off with the STONITH mechanisms. So I mentioned, obviously, the split brain detector over storage, SSH, power switches, etc. One of those is, I can't remember the exact term, but it's effectively the human option. So the monitoring system flags it as failed, but the system does nothing. But then you just pop into your pacemaker and say, yeah, okay, it's really failed, and you move it that way. Cool. So I used to use that back when the software was in that kind of slightly weird stage. For me, I've luckily never used a cluster stack that was that bad, but I heard stories about Heartbeat back then. But yeah, now I can't think of a situation where I've had many false positives with any of this software, or false negatives. When it fails, it really has failed. And you have lots of options like actual monitoring of services, so you can actually see, okay, is my website actually responding to users? And use that as your failure condition, not just a random ping to the machine, which in certain circumstances the pings might not be working, but the web server's still fine. So you can easily set up your HA stack to actually monitor the real service in the way that a user's going to see it. And then, okay, you might have a transitional problem, but at least it's a problem that a user really suffered, so it was probably worth killing the machine off and moving it over.
Cool, thank you.
Yeah, so HA Cluster Bootstrap, this is Tumbleweed, and now you ignore that error, because this is Hawk, the web interface, which at the moment is getting redesigned, and at the moment it's slightly broken in Tumbleweed. But I'm not demonstrating that. Christopher's demonstrating it tomorrow in which room? Second room at what time? Okay, so just before lunch tomorrow, in that second room, if you want to see the shiny new Hawk web interface and how you can actually use it for diagnosing a problem on a HA cluster, Christopher's doing a talk in there. So luckily, I don't have to show it at the moment. And I really should have put these packages on before, but it's not that big. It will hopefully install quite quickly. So yeah, this is pulling through all the Corosync stack, all of Pacemaker, everything I need to get running. There we are. So HA cluster init. And straight away it's telling me that my machine is not set up properly. I'm missing NTP and I haven't got my hostname set up right. But both of those are non-critical failures. I mean, it's going to break things if I did this in production, but for a demo it's fine. So I can click yes. It asks me here which IP address do I want it to bind to. It tries to auto-detect the IP address of the machine. So in this case, it's realized I'm on the Wi-Fi network and given me a Wi-Fi address. I'll just accept it for this. By default, HA will use multicast. You can use unicast instead for communicating between all the nodes, making sure that everything's still there. But by default, it will use multicast, and this script will randomly generate a multicast address for it to use, so it doesn't clash with your other clusters on the same network. There's the port. I don't want to use SBD because I haven't got shared storage on my laptop. And it fails because I didn't install Hawk. Demo effect, wonderful. Yeah, if I did have Hawk installed, the web interface would then start at this point, which just basically says, hey, go to this URL. And in the background, all the rest of the cluster services start up, and that's your first node cluster up and running. So that's all you need to get a HA cluster from square one. And then add your second nodes. It's just that simple, run that wizard. And in fact, for most of those questions, I said, I accepted the default values. Now my presentation might start again. Hey. There we go. Yeah, for most of those options, I just accepted the defaults. So if you're doing this in like some kind of automated environment or cloud or whatever the heck you feel like doing, you can normally just run HA cluster init -y, and it just says yes to everything, and you immediately have a cluster set up, which is really good for testing and doing crazy stuff. So if you want to learn more, well, obviously Christopher's talk tomorrow. Or the documentation, the best documentation we have on it at the moment is actually the SLES stuff with SLE12, because it's very, very similar to what we have in 13.2 and in Tumbleweed right now. So the HA extension details are there. It goes into great detail about pretty much everything you could possibly wonder about, but with DRBD, I quite like the upstream documentation as well. So there's the link for the website there. And then if you want to get hold of me, Christopher, anyone else who's involved in doing HA, the HA develop on Freenode is actually a cross-distribution IRC channel where we're there from the sort of SUSE and openSUSE side, and there's also Red Hat, and I can't think of other. Yes? Is it now? Did we alias it? Because I'm not joining Cluster Labs, and I still get plenty of traffic on that address. Okay. It should be Cluster Labs, not HA Devel. I think that's an alias because I still get plenty of traffic on it, but yeah, it should be Cluster Labs, not HA Devel, fine. Or the openSUSE mailing list, which at the moment is very low traffic, but that's part of the reason I'm here, so we can hopefully change that. And with that, thank you very much. Any last questions? Because I've got like 30 seconds left. Yes.
So I can just explain what happened with Hawk. So Richard is using on Tumbleweed, and Hawk is a Ruby on Rails app. So every time someone checks in a new version of any Ruby gem that we use in Hawk, it breaks. So if you want to use it in production, you probably don't want to use on Tumbleweed, but you probably don't want to run cluster in Tumbleweed in production anyway. So.
Yeah, I think I'm the only person who's ever actually done that, and I did it because I was kind of on a bet. But yeah, but it's there for testing, so that's fine. Cool. Anyone else? What I'm saying is, if you're interested in high availability, okay, let's see how I can spin this. If you're interested in high availability, you probably want to run it on the regular release. Because you're normally, high availability, you're talking about something that's very, very stable. You know, updating every day in Tumbleweed. I mean, Tumbleweed is great. Tumbleweed is wonderfully fast, but are you really going to patch Tumbleweed every day in a HA environment? Probably not. So you probably want to have something that moves a bit slower. That's probably a case for the stable release. So if you're the crazy kind of guy who wants to have their server patching and rebooting every day, HA will give you some interesting ways of being able to handle that, because you can just reboot a node every day and your cluster should carry on working. But yeah, let us know if that goes horribly wrong. Yeah, because that's not really a traditional use case for HA.
So yeah, there's another thing that you mentioned before, that when you add HA software, you actually get lower availability. And in a sense, that's true, because like the biggest enemy for stability is complexity, right? And by adding more software, you're adding more complexity. So you do have like a step back there. But the thing is, if you start chasing, the nines in 99.99% uptime, you really need to be able to respond to failure very, very quickly. And the only way to do that is to automate the recovery, which means you need to have a really stable application that you're trying to run highly available and so on. So there's, it's not, you don't just add high availability software and everything gets better. In actual fact, it gets a little bit worse, but yeah, thanks to that, you can get a little bit further.
Cool. All right then. Thank you very much.